hello everyone. Thank you for having us on what is also our Wireless LAN Professionals Conference debut. We're very excited to be here. So who are we? Very quickly, I'm Matt and this is Mac. We are both wireless project engineers for Netilik,
And you can also know us as WiFi Ninjas podcast and blog.
So today, get excited because we are talking to you guys about the most exciting thing about Wi-Fi.
Yeah, it's not Wi-Fi 6 anymore. That's yesterday's news. No, it's RTLS, so real-time location services.
Yeah. Here are a few of the vendors and the technologies that we'll be covering, but we thought we would give you guys. Oh, is that thing right? Sorry.
Oops.
There's a cable.
It's not looking good.
No, some technical issues, but okay, never mind, we'll move on. So we're going to cover today the different technologies that you need for RTLS, the different types of tracking methods that there are, and the different types of functionality, and then what you need to do a RTLS RF design. And then we'll have some examples and demos for you guys.
And that's a really shame that we didn't see the last slide because it was like a jumping puddle, very excited as both of us are.
Don't know why it didn't work, but.
Okay, so we'll also talk about why we would need RTLS. And RTLS can be used for tracking assets for indoor wayfinding, finding your host, finding your meeting room, finding anything you want to find. And you have a very real use case that you really would like to use every day.
So I don't know if this happened to any of you guys before, but this has certainly happened to me that if you go to visit a client site, and it's a very nice client, they may offer you a coffee when you get there. You have the coffee, and all of a sudden you need to find your toilet. Wouldn't that be nice if you could just pull out an app, put it in there, where's the nearest toilet, rather than having to go around asking someone, where is it? So yeah, that was one of our interesting use cases before.
Yep, so when you found it, you can also use the RTLS for the marketing. You can use it for the engagement and actions with your clients. And you can use it for the network-wide presence and analytics stats.
Okay, so who would want to use RTLS? Well, anyone that works in retail, hotels, hospitals, any like public spaces, enterprise offices, and then potentially if you've got a large enough house, maybe you'd want to do that, but probably not in the UK.
And that's what we are going to test today in the live demo. So we are testing Wi-Fi trilateration with different vendors. We are testing Wi-Fi hyperlocation with Cisco, Mist implementation of vBLE arrays, and we'll also touch upon some API integration leveraging CMX also. Cool.
So we'll just cover quickly the different wireless technologies that you can use for tracking. The first one being Wi-Fi, which is generally the most popular tracking method because it also provides access to the network. You can get different methods and levels of accuracy through Wi-Fi, which we'll cover in a couple slides' time. Client applications, they're optional, but they're quite challenging because there's no way of the application of knowing the Wi-Fi MAC address of the client that it's on. And then the APs track the client signal and then feed that off to a server or cloud to compute the station location.
Yeah, and moving to more interesting bits, it's BLE. So you must have heard about the BLE and vBLE and what is the difference. So normally BLE is like a BLE beacons, battery operated devices scattered around the premise. And vBLE takes this functionality and puts it in the access point. And also having it in the access point, you can define like a virtual places on the map, which will trigger different actions for your client. So it's cool. Potentially, BLE can be more accurate than Wi-Fi because the signal deteriorates faster when you move away from the beacon. And is BLE transmitting and receiving data? So normally BLE beacons data, but not only anymore. So you can receive or transmit data using BLE. And clients applications are optional but recommended. We'll talk about clients applications a little bit more later on. But the difference in comparison to Wi-Fi is that the client tracks BLE beams and it sends the BLE beams information back to the server, to the cloud, and that's where the location is being calculated, and then the location is being sent back to the client. So it's completely different than Wi-Fi.
Okay. Now there are a few different methods of RTLS tracking. The first one, cell of origin, the most simplest, just like Mac, is usually where the It's usually where the AP first hears a client and it's of the strongest RSSI. It can be predominantly used for zone-based level accuracy only, and XY coordinates are not calculated.
Okay, and this leads us to a very complicated method, similar to math. That's a triangulation, and it requires not only one AP, like in South origin, it requires at least 3 access points. So you're using the RSSI to calculate the location of a client inside a zone. So not only zone accuracy, you can have more accuracy inside the zone. XY coordinates naturally are calculated, and the marketed accuracy is between 5 to 7 meters, but we'll talk about it later.
Okay. The next method is angle of arrival, or angulation. This is a slightly more accurate form of tracking compared to trilateration. If you think of here, if we talk about Cisco like hyperlocation access points, they have the multiple element antenna arrays. If you talk about the 4800, these are built in. If you go back to a previous generation where it's like the 36 or 3700, you'd have to get the external halo module to cover that. You really need to have at least 2 sensors to be able to track the client here, but ideally you need to have 3. The marketed accuracy for angle of arrival is 1 to 3 meters, and XY coordinates are calculated.
Okay, and last but not least is the implementation of vBLE arrays from Mist. So this is actually quite cool. Mist access points, they have 16-element arrays, antennas built into their access points based on BLE. And these are directional, they create like directional beams around the access point, 8 of them. And the client is listening to those beams and sends this information back to the Mist cloud. And based on that, Mist cloud can calculate the location of a client. And not only that, they are like using some crazy stuff like probability surface and machine learning to create a profile of a radio of a client, and it's being done automatically. The more you walk around, the more accurate it gets, and then you start using a default profile, then it's getting really, really good for your device. So that's amazing.
Okay, so just moving on to the functionality. The first one being the presence and analytics. This typically relies on Wi-Fi, so this will be giving you your network-wide stats. So how many visitors have you had? What are the different device types, like the dwell times? Are they repeat visitors? What devices are coming into your network? All of that kind of information.
And then you have a location, which is a live location. So a blue dot experience, locating clients on the map or the asset on the map, and like zone analytics, zone paths that the clients are taking. It can rely on multiple different technologies. Most widely used are Wi-Fi and BLE, but it's not limited to that. It can be ultrasound, magnetic, GPS, and mobile networks too.
Okay, and then finally is the engagement and actions, which uses the presence and analytics information alongside the location to create a more personalized experience for the user. Give you an example, say you go to your favorite shopping mall, the Wi-Fi Ninjas shopping mall, and whilst you're there, you decide to go buy a pizza from the Wi-Fi Ninjas pizza place. You then could get tagged with a pizza lover tag. So then when you next return back to the shopping mall, you get sent a push notification to say, hey, welcome back, go enjoy a 50% off on us today at the Wi-Fi Ninjas pizza place.
So now moving on to the design tips for the RTLS. So design tip number 1, APs should be located around the perimeter of the area that you want to cover.
Yep, and then each client should ideally be inside of the access points. Of at least 3 access points, you need to have a good solid RSSI for this.
And also ideally, if possible, it's really good to use the dedicated RTLS radio for the RTLS functionality. This makes the client-serving radio more efficient because it doesn't have to do any RTLS.
And try and ensure that line of sight is maintained between the access point and the client. We never recommend that you install APs above ceiling tiles anyway. It's a big no-no, but especially with your RTLS.
And don't mount access points too high. So 2.5 meters is fine, 4.5 is stretching it, but 10 meters warehouses and stuff, it's just like, don't.
Okay. And then finally, the last one is to validate your secondary and tertiary signal strength in your favorite survey tool. We only have one, so we're going to show you how you do that in Ekahau. You can go to the options and then view the tertiary signal on the all channels, and it will show you that if the APs have got tertiary signal for your coverage requirements.
Okay.
Yeah, quick example.
Yep. So this is our Natilic office, one of the floors, and you can see that here it's enough to cover the office with a good coverage, with a good capacity for the amount of clients sitting in the office with just 6 access points. But that's, the key word here is data. So that's what it's designed for.
So now to show you what it would look like if you used to do an RTLS design, you can see that the number of access points has tripled. Why has it tripled? Because we need to create that convex hole by putting the APs around the perimeter. We have the AP in the center because that's creating our trilateration. It may look like it's a bit excessive down the bottom with the boardroom and the meeting room, but it's really thick walls, so it attenuates the Wi-Fi pretty good. So that's why we needed the extra access points here.
And not only walls are thick here. So demo time.
Okay.
So this is our test environment. We have a really good looking model walking around a house. In my house we have an open space about 7 by 9 meters, and we have 3 tripods located very strategically in the corners using laser tools to have a height of the access point. They're all pointing north and they are very well leveled too.
So Wi-Fi trilateration is our first demonstration and test we've got here. Very quickly just cover the components needed to do this with Cisco. You need to have Cisco access points, Cisco wireless LAN controller, Cisco Prime, and then Cisco CMX. And then you've got the and/or potential of DNA spaces, and then possibly you could...
Yeah, one day, we're using 9800 controllers from Cisco, and theoretically, at one point you will be able to connect them directly to DNA spaces without having to use CMX for trilateration. But the code required for it is 16.12.2, I think, and the newest publicly available is 16.12.1.
Yeah. And then now with Meraki and Purple, you need the Meraki access points, Meraki dashboard, and if you'd like some more insights and stats, you can integrate that with the Purple dashboard. And then here we're giving you a live location view in Cisco DNA spaces and the Meraki Purple. You can see here basically probing and probing only, and then associated clients. And then on the Meraki dashboard with Purple, we can see that a client is logged in with social media platforms, so you get a lot more information about the client now. So you can see things like their age, gender, where they came from, and all that sort of information and stats.
And the accuracy. So we've had a perfect lab conditions. We had the access points in the good locations. They were not too high, not too low. They were perfectly mounted. And we have 3 spots on the map, which is inside the convex hull of the access points, on the edge, and outside of the convex hull. So we wanted to understand how it's going to affect the accuracy of the trilateration test using Wi-Fi RSSI. And inside, we had the accuracy of around 2.7 meters with 90% of certainty. And when you move to the edge, it goes down to around 3.4 meters. So in a lab, we had a slightly better accuracy than marketed, 3.4 meters, 3 to 4 meters, versus 5 to 7. But in a real environment that we've put the RTLS based on Wi-Fi RSSI, we had accuracy of around 7 to 10 meters, and that's good if you can have that.
Okay, so now moving on to the Wi-Fi hyperlocation testing that we did. Just a quick look at the components that we needed for this. We needed the hyperlocation access points from Cisco, Cisco wireless LAN controller, Cisco Prime infrastructure, Cisco CMX, and then you can optionally integrate that with Cisco DNA spaces as well. And then what we're showing you here is the CMX server at the Natilic office, and more in particular here, the zones that we've created on the floor. And what we're trying to point out here is the showcase. The showcase is somewhere that you can come if you are a new client to Natilic and you want to have a new technology demonstrated to you. You can come to the showcase and see that before you buy it. Why is that interesting? Well, here we're looking at the path analytics of where clients go to before they come to the showcase and then where they go to after. Maybe in an office environment that's not as interesting to maybe someone, say in a retail environment, that they get an understanding of the flow of their building, so they could put targeted marketing in different areas, targeted specifically to different clients coming there for a different purpose. So, yeah.
And that's the accuracy of the hyperlocation. So you can see that the circles around the test points, they are much smaller than with trilateration, and they're quite crazily small when you are inside the convex hull. We had 73 centimeters of accuracy with Cisco hyperlocation inside, which is absolutely mind-blowing. When you go to the edge, it goes down to around 2 meters. which is very well within the marketed accuracy of 1 to 3 meters. But in the real world, it really depends. These are the tests like, stop and go. When you start walking quickly around the premise, it will be slightly less accurate.
Okay, we have a video here, but I'm not sure it's going to play if I just click, so I'm going to play on here. Okay, so just talk you through this video. On the left-hand side of the screen is a recording of my iPhone where I downloaded the CMX Server iOS app. The middle screen is the CMX Server appliance, just tracking purely my MAC address, and then on the right-hand side is me walking around Mac's very nice furnished home here. And then what we can see on the screen is the blue dot experience. We couldn't find any easy way of drawing a wayfinding path in CMX or how to do it, so this is purely just updating our location based on the accuracy of where the access points think that they are, feeding it back into the CMX server. For this testing, we actually thought this was pretty good. It was pretty accurate. There's a few times it jumped us around a little bit, but most of the time it was updating fairly regularly to where I was kind of moving. It was always within the marketed accuracy. So yeah.
Yeah, and the location calculation frequency was around 2 seconds, slightly more than that. So it really feels like it's kind of real life. It's really good. And having in mind that we didn't have wayfinding paths that snap you into your position to make it appear better than it is, it was very good. Okay, and now let's move to the Mist vBLE.
Yep, so moving on to our Mist testing, we take a look here at the components necessary to be able to do location analytics with Mist. Access points that connect straight back to the Mist dashboard was all that was needed. So
yeah, very complicated.
Yeah, not too complex here. And then here is just a couple of screenshots of the location view inside the Mist dashboard. We can see the floor plan and the kind of like presence and analytics stacks where we've got how many people were there, the dwell time, the different devices, and all that sort of information here.
Mm-hmm. And now accuracy test of Mist. So this is, yeah, let it play. It's a beautiful song. So we have our favorite model walking around, and you can see in the central part that our favorite model has just hit the kitchen zone, and then he's getting very close to an orange circle, which is our browser alert that should trigger opening a website, because he's close to the kitchen, so of course he will be interested into having some coffee. And he's moving around the blue line, which is the wayfinding path that makes it appear more accurate than it really is, because it snaps him to the path. But it's cool, we don't care, because it really feels great. And you can also see that we can see on the central screen that we are leveraging compass. And this is, the most important thing. He just hit a very good website, WiFi Ninjas. We've just seen some David Coleman reference there, so thank you very much for having an episode with us. And this is really mind-blowing. It's so quick. Boom, it's amazing. So yeah, it refreshes like every second, and both on your using mobile SDK on your phone and in a dashboard every single second. So it's absolutely mind-bending. What do you think, Matt?
No, it was really good. From how simple it was to set up and deploy to how accurate it was and how quick to do in the testing, it really, really impressed us. So,
big time.
Well done, Mist. Okay, make sure it's try. That's going to play again. Okay. So moving on to our actual example now from where we have deployed some location information. And thank you very much to Liberty London for allowing us to talk about your deployment here. I'll just give you guys a little bit of a background about Liberty for the guys that may not be familiar. It's one of the oldest shops in the UK, in London. It's a very, very nice building. What they're known for is selling lots of luxury items. And then they came to Natilic because they needed a Wi-Fi network to match up to the prestigiousness of the building.
Okay, so what we can see here is a ground floor of a Liberty shop, and we can see some zones, colorful zones that we've defined, and the network was designed for data. It wasn't designed for the RTLS, so we put it in. It was based on Meraki. It works great. It's very reliable. And then we had a presence and analytics stats from Purple on top of it. So we wanted to have like, everything nicely visualized, like all network-wide stats nicely visualized, because here, with this design, using Purple and Meraki, we do not have the location accuracy that we would be willing to have if we were after the, I made it sound complicated. So with data design...
That's not like you at all.
Yeah, no. It's not possible to have a proper trilateration, like, accuracy within the zones. So for that, we would need to have more access points. And Liberty was fairly interested into having more insight into zones analytics. They wanted to understand where the clients go, between which zones, and how many of these clients are returning, and if they change something inside the shop, does it change the path that the clients are taking? These are very, very important things for the business to understand. But with design for data, we cannot leverage Meraki trilateration to give us more information about the location of the clients. Purple is supporting most of the vendors in the market, and they are using pre-calculated XY coordinates from these vendors. And Meraki is using trilateration, so Meraki would really use the access points from multiple different zones, because each zone has just 1 or 2 access points. And we have quite a lot of atriums there as well, actually 3 in every section of the building, which would make the Meraki to use APs from multiple different floors, because there's a line of sight between these floors, to calculate the location. And the users would develop superpowers. So they would start on the ground floor, and 3 seconds later they would fly to the 5th floor. And it's just not reliable enough for us to leverage Meraki trilateration.
What we're basically trying to say here, anyone that shops in Liberty London have superpowers, because we're just seeing them fly between the floors.
Yes, so we have taken the superpowers away by leveraging Meraki Location API. So our end goal was to have zone analytics to understand which zones the clients were moving from, to how much time they spend, and so on. So we know exactly where the access points are located within those zones, right? We know where they are. So if we know which access point the client was associated to, so we are just using cell of origin here, or which access point is seeing the client with the strongest RSSI, we can clearly say where the client is with a zone accuracy. So here, this is just an example of raw data from Location API from Meraki. We have like AP mark, we have time that the client was seen, we have client mark, and we have a venue, which is a zone. And then this information was taken by Liberty software experts, software development team, and they made it look very pretty, and they visualized the zones that that the users were taking, which is just a tip of the iceberg.
Okay. So that was one example of the location API, and then now we're going to cover the location API that we've leveraged at Natilic. At Natilic, we are also very fortunate to have a very skilled developer there by the name of a guy called Deryng. And what Deryng had done, he had created a chatbot that integrated with WebEx Teams, which is now called NatBot for Natilic and Chatbot. Now we had a look at this with Deryng, and we were trying to think, well, we've already got a Cisco wireless network deployed in the Natilic office. What other cool things can we do to maybe enhance the experience of the users at Natilic? So we decided to deploy Cisco CMX. And with Cisco CMX deployed at the office, we then pulled an API from Cisco CMX into the chatbot. So now when you ask the question to the chatbot, like, oh, who is this person? It can come back and it can return information of like who I am, but also one of the early stages of testing that we were doing, it was just sending back a nice little message. Hey, if you're in the London office today, they're on this floor, why don't you go and say hi? After a few more months of testing and playing around, we decided to come up with another feature. I'll just play a short video here of live asking the chatbot where someone is.
What about the next integration?
Wait, it's coming. So here we can see we're asking the chatbot where is James Hinton? He is our model for this. It returns back a floor plan, and there's some icons there, but you can't see too well. But the third icon is basically taking you off to Mapways, which is a indoor wayfinding path service, which draws a path from your current location to the location of where James is. And I don't know about you guys, but if I was, Natilic now has around 200 employees. If I'd only just recently joined Natilic and I wasn't sure on who everyone was or where my meetings are, if I could just go onto a chatbot and say, hey, where is this person, or who is this person, get some more information about them, start to know where they are, and just all that information, I would find that much easier and better. And we think this is pretty cool, right? I mean,
It's extremely cool, and here you don't even require an app. The only drawback of not having an app on your phone is that you do not have a blue dot experience there. So it just like, it takes your starting point, it takes your end point, who are you looking for, and it draws the location there. But sky is the limit here. Yeah. So what we can really achieve is try to imagine integrating this functionality with like voice assistants, like Alexa, where is Matt Starling? It would be quite cool, I think. It's more of a gimmick, but it's a nice one.
Which we just had a question from the guy at the back, like what about integrating Alexa? So you must have known our next slide was coming because
someone has stolen our slides. Yeah, but we will do it. That's on the table. So
I want to ask Alexa about it. So.
Okay. And also you can add like full wayfinding functionality, so you can leverage mobile sensors on your phone, like a compass. You can use like a Google Maps and offload the in the location to out the location to have full end-to-end wayfinding functionality. And this is just a start. And we have multiple different vendors here, and we integrated the functionality between them using the API, which is very, very nice, I think.
Me too. So just a quick summary then of the accuracy between Wi-Fi trilateration versus the hyperlocation. The trilateration is the solid lines and the hyperlocation is the dotted lines. Just a quick visual here for you guys to see. As expected, the hyperlocation testing was much more accurate than the trilateration testing.
Okay, and very quick summary, I won't go about the accuracy again, but the very important thing is the calculation frequency of the location of your client. So when you are using trilateration, like RSSI based technique, your location is being calculated every 11 to 15 seconds with Cisco. And this will not give you a blue dot experience that you might expect from a live location, but it's still, very good for the live like zone analytics and this kind of stuff. So it's still not too bad. But when you think about the hyperlocation, the computation frequency goes down to about 2 seconds, slightly more than 2 seconds. So we've seen on a test where Matt was walking around the house where it felt like a real time, and it was just every 2 seconds. With Mist, we have every second now, which is absolutely mind-bending, and it feels right. And now what happens when you put your phone in your pocket? It's still associated, it's still active in the network, well, kind of. And then with hyperlocation, the computation frequency will go down to around 4.5 seconds, which is still all right when you're after just looking at your dashboard and understanding the movement patterns of your clients.
So there's a few gotchas with implementing RTLS that we're going to just quickly share with you. The first one being NTP. If you're using Cisco hyperlocation, NTP is crucial to be synced across your access points, your controllers, and throughout your network.
Yeah, absolutely, and make sure that your components of your solution are compatible with one another. I spent ages building the newest available boxes, recommended versions, and it just didn't click. Then I checked location matrix. I should have known better. And yeah, it's very important because we have quite a few elements that are building our location tracking solutions.
Especially with Cisco. Mm-hmm. Okay. AP mounting, if you're using the Cisco hyperlocation access points, they have a little arrow on them, and if you're using the Mist access points, the Mist logo, it's crucial you understand which way they are facing, because the next gotcha is the fine-tuning of the maps. You need to be able to correctly tell the map services which way the access points are facing, the height. So just a recommendation from us to you guys, if you are going to be doing location analytics for anyone, is we tell our cabling guys when they're going to do the installation, if you're looking at the map to install the access points facing in one direction, so pick like east or north or something, and then it will save you time when you're doing your fine-tuning of the access points later on in the maps.
Yeah, and we got it wrong for the first time when we were testing Mist, and it didn't work too well. Yeah. And don't mix hyperlocation with non-hyperlocation. So if you have clients associated to non-hyperlocation standard access points, and they are both in your controller and prime and stuff, it will a little bit make it less accurate than you would have liked.
Mm-hmm. And then really trying to get the Wi-Fi clients associated, because they'll improve the accuracy greatly. And then also some Wi-Fi clients do not probe at all, so you may not even know they're in your premise. So do what you can to try and get the clients associated inside the network. One of the ways of doing that is by using mobile applications to encourage people to connect to the network. It will leverage better analytics information for you guys and experience for the clients.
Yeah, and mobile applications, they are very, very important. Like especially what happens when you don't have a mobile application on your phone when you are trying to leverage BLE with Mist. So new phones like Android and iPhones, they are sending some information using BLE. And the BLE receivers on the access points, they can receive this information, but it's not frequent enough to make it like real life. Your phone will be seen as an asset in the network, which is, you know, in some use cases it's fine, it's totally cool. But if you want to make it like really real life, then the application is not optional, but required. And lastly?
Okay, yeah, and the final one being, if you're trying to use a Cisco C9800, the new wireless LAN controller, when you add it to CMX, you need to specify it as a unified wireless LAN controller, which leverages SSH rather than the other way, which leverages SNMP.
Yep. And if anyone is interested into, like, you know, location tracking and have some questions, we are more than happy to answer them all.
After the presentation. So
after lunch.
Yeah.
We know, yeah.
Thank you guys.